All right, so good morning, everybody. This is January 23rd. I want to remind everybody that your web assigned homework from section 7.1, and then there's a homework assignment from 7.2 and 7.3 combined is due January 28th. And so that is your first assignment that's due. There is a grace period. So if you haven't signed up for WebAssign yet, remember that there's a grace period so that you can go ahead and can start working on WebAssign before you've actually paid for the access code. So kind of keep that in mind that you could go ahead and register, and that's what I want you to do so you can get started on your homework and not get behind. The grace period ends 24th, 25th somewhere, and so I'm hoping to get that postponed a little bit through WebAssign because of our weather delays from last week. So I'll keep you guys posted as to how that goes. I'm working on that today, so I'll keep you posted if it goes any further than that. So, Augustina, can you hear me? Augustina, can you hear me? Yes? I guess you're raising your hand to say yes, or do you have a question? Okay. All right. So she can hear me, so that's good. Trisha, can you hear me? Trisha, are you there?
Yes.
All right.
Yes,
Okay, I can hear you just fine. Okay, sounds good. So welcome you guys that are new this morning. Augustina and Trisha, you're new as far as attending live lecture, so welcome. We're in the middle of talking about WebAssign. I want to remind everybody that those WebAssign first two assignments are due on the 28th. And again, like I mentioned a second ago, I'm going to try to get the grace period extended. Right now, the grace period extends up through either January 24th or 25th. So just in the next few days, it's going to expire. So get started on WebAssign. If you haven't already, get working on your homework. Don't get behind on that. Online office hours. I want to remind you that I do have online office hours on Sunday and Tuesday from 8:30 to 9:30, and then in the evening, and then Tuesday, Wednesday, and Thursday from 11 a.m. to noon. So I wanted to keep reminding you that you can come by my online office hours. And let me give you an example. On Sunday, I had a calculus student show up for online office hours, and he and I worked on problems for 30 or 40 minutes. And so, he had my undivided attention for 30 or 40 minutes, and we worked through quite a few homework problems that he was having problems with. So that's always a good opportunity to come by for help. And then remember, if those hours don't work for you, we can try to make an appointment at another time that's convenient for the two of us, and we can try to work out another time to meet on online office hours. I want to start talking about Exam 1. Exam 1's window opens February the 8th and runs at February the 8th through the 13th. Remember that you take the test in a testing center in the Lone Star system, unless you've worked out something with me for a college at somewhere else. But you can use any of the testing centers in the Lone Star system. You just need to have a photo ID. I would allow probably 2 hours to 2.5 hours to take the test. It should not take you that long. Most people will finish it between an hour and a half. But you just want to give yourself enough time so that you don't have that pressure on you. And I will typically put a 2 hour and 30-minute time limit on the exams during the semester, so that that'll give you plenty of time, but you ought to at least give yourself that amount of time in a testing center so that you're not pressed for time at all. In case something happens, you run into a problem that you struggle with, and then you get behind on the test, and then you kind of panic at the end. So today we're going to finish factoring. We've started talking about factoring polynomials, so we're going to look at section 7.3 on factoring trinomials and finish that up, and then look at section 7.4, factoring perfect square trinomials, and then factoring binomials also. All right, so before I get started, does anybody have any questions that they want to ask me before we get started with the material?
So for the online office hours, we could just join
Yep.
at the
Yeah, online
at
on
the time.
that's Raina, that's right. Online office hours. You just show up. I'll open up the WebEx room just like I do for class for lecture. You just go to that same link, and I'll be online, and then you can just ask questions.
Okay.
Yep. Any other questions at all? All right, then we are going to get started. And so today we're talking about factoring. We're going to finish talking about factoring. So let's kind of talk about factoring again to kind of get things set up here. Remember, and we've talked about this in class, that factoring polynomials means rewriting a polynomial as a multiplication problem. Right? And what we are doing currently is we are exploring ways to do that. Right? And there's different techniques for taking a polynomial depending on how it's written and writing it as a multiplication problem. All right, so factoring, first step. Remember, the first step is always, and I mean always, look for a GCF. Right? Before you do anything else, you always look to see if there's a common factor in the polynomial that you can take out, something that's common to every term. And then after that first step, the second step then, after you deal with the GCF, is to look at how many terms you've got. And if you've got 4 or more terms in the polynomial, then you try grouping. I'm going to say try grouping. It doesn't mean it has to factor by grouping by any means, but you try grouping if you have 4 or more terms in the polynomial. If you have 3 terms in the polynomial, remember when a polynomial with 3 terms is called a trinomial. And so what we're doing is we're taking trinomials and we're actually splitting them up. This is the way I do this. And you've probably, most of you have talked about factoring trinomials somewhere before. And I may be approaching it differently than the way you've approached it in a different class. That's fine. There's nothing wrong with that either way. And I don't necessarily care that you use the techniques that I'm talking about in class here or in lecture. It doesn't really matter to me as long as you have an algebraic technique that works for factoring that you're used to, then I'm okay with it. So don't think that you have to be locked into the methods that I'm showing you in lecture. But the way I divide this up is I look at what I call easy trinomials. And an easy trinomial is one where the lead coefficient is a 1. And we talked about those already. That's what we finished with last time in class. So lead coefficient of positive 1. And then you have an easy trinomial. And then the next step, or the next category for trinomials are what I call not so easy trinomials. And not so easy ones, obviously the lead coefficient is not equal to 1. Is not equal to positive 1. And the method that I'm going to use here is basically a version of trial and error. Now, trial and error does not mean guessing. And I want to make sure you understand that. Definitely not. And we're going to talk a lot about that in class today. And then we're going to finish with trinomials by looking at perfect square trinomials. And how do I identify a perfect square trinomial when I see one? So how do we pick these out? Right, and then, okay, so we're going to go through those 3 ideas with trinomials, and then finally we're going to look at binomials. And so polynomials with 2 terms. And these are called binomials. And binomials, factoring binomials is all about patterns. And that there are 3 patterns that that you can use to factor a binomial. And they have names. One's called the difference of squares. And that's if you have a perfect square minus a perfect square. So we're going to talk about how to factor that. And then we have the difference of cubes, where a polynomial is in this form, a perfect cube minus a perfect cube. And then finally, we have the sum of cubes, which is a perfect cube plus a perfect cube. And so we're going to talk about how each one of these can be rewritten as a multiplication problem. And we're going to do that today also. All right, so this is what we're all about today. So first step, look for a GCF. That's our first step here. And then if you've got 4 or more terms, you're going to try grouping. Right? If you've got 3 terms, then you've got these 3 possibilities. You've got either an easy trinomial, a not so easy trinomial, or a perfect square trinomial. And we're going to talk about how each one of those can be written as a multiplication problem. We've already done the easy ones. And then finally, we've got polynomials with 2 terms, or binomials. And we've got these 3 ways that those factor: the difference of squares, the difference of cubes, and the sum of cubes. So we're going to learn how to go through and kind of work our way through all these different techniques for rewriting a polynomial as a multiplication problem. All right. So we're talking about trinomials right now. So that's our initial goal here, is to finish up talking about trinomials. So we've already talked about easy trinomials. Is there a question? Does anybody have a question? Tricia, do you have a question?
Yes. Okay. So the notes that you're writing right now, is there a way that we could be able to get a copy of that?
I post all these notes, Tricia. So Tricia's question, for those of you who are listening to this recorded later, Tricia's question was, can you get copies of these notes when I write them down? And remember, 2 things is that I always upload to YouTube just a recorded version of this lecture with all the audio and the video from the screen and everything. But then I also just upload a copy of the notes, just a static copy of the notes. And those can be found at the bottom of my Google site. So if you go to the bottom of the Google site for the class, there will be 2 different places there. One that says go to YouTube for the recorded versions. And then the other one is just a copy of the notes with no audio or video. Okay? So Tricia, yes, you can always get a copy of these notes, and you can upload them because they're all going to be PDF files. Not a problem at all. Is that okay?
Thank you. Yes.
Yeah, you're welcome. Good question. Good question. Yeah, because we want to make sure that everybody knows how all this works. I know a lot of you are not used to how I'm setting things up and everything. I understand that. So, all right. So let's talk. Let's see where we are here. So with an easy trinomial, so if you have a polynomial like this one right here, x squared plus 4x minus 21, right? This is what I've been calling an easy trinomial, because the leading coefficient is a 1 right here, right? This number in front of the squared term at the beginning is a positive 1. And remember, with an easy trinomial, all you're doing here is you're trying to answer this question. You're looking for factors of negative 21 that add to give 4. Right, and it's always going to be the case. You're looking for numbers that multiply to give that last number, but add to give the middle term, the coefficient of the middle term. So you're looking for 2 numbers that multiply to give negative 21, but these same 2 numbers have to add to give positive 4. And relatively easy, isn't it, right? You get 7 and negative 3. 7 times negative 3 is negative 21, but 7 plus negative 3 is positive 4. So those are the 2 numbers that we want. And we use those in the binomials that we're setting up, the binomial factors. And boom, we've got this this polynomial factored. Don't forget that you can always, for any trinomial, whether it's an easy one or not so easy, doesn't matter, you always just look at the inside two and the outside two terms and make sure that those add to give the middle coefficient. And as long as you can get them to add the middle coefficient, then you're good. All right, so that was an example of an easy trinomial. This is also an example of a easy trinomial. I'm looking up, making sure I'm getting some out of the book here. So you've got, let's say you've got 2y squared minus 16y plus 30. Now at first that does not look like an easy trinomial, but remember it has a GCF. So GCF is always first, right? And the GCF in this problem is 2. And when you take that 2 out, sure enough, you're left with an easy trinomial, right? And so now you can factor it just like we were talking about on the previous problem. So you're looking for two numbers here that would multiply to give positive 15, but these two numbers would add to give negative 8. Don't forget also that the 2 just comes down for the ride. Don't make that 2 disappear. Don't play magician here, right? You want to keep that GCF sitting out in front as a factor. And so let's see, what two numbers multiply to give 15 but add to give negative 8? And that would be negative 3 and negative 5. Whoops, negative 5 right there. Right, negative 3 times negative 5 is positive 15, and negative 3 plus negative 5 is negative 8. And so this polynomial will factor as y minus 3 times y minus 5. Also, don't forget that if you wrote those factors in the opposite order, if you wrote y minus 5 times y minus 3, it's multiplication, so it doesn't matter. So that's okay, right? Both of those are correct. Order does not matter here at all, right? You can write those factors in either order, and it's going to be the same factorization. All right, so this next trinomial is an example of a not so easy trinomial. And we'll start off with some that are going to be relatively straightforward at the beginning, and then we're going to gradually work our way up. So, it's not going to be that they're all going to be difficult here from the get-go. We'll take our time getting through these. So this first problem is going to be 2t squared plus 7t plus 5. Right? This is a not so easy trinomial because of this 2 right here. And so it no longer works that you're just looking for two numbers that multiply to give 5 but add to give 7. That doesn't work anymore. Instead, you've got, you know that this is going to factor as two binomials. And what you know is that there's going to be a t in the first term of each binomial. You know that. What you don't know necessarily are what the coefficients of the t's are. Now, in this case, since it's 2t squared, there's really only one possibility. But I'm going to treat it like I don't know that. And so you write down all the factors of that first coefficient. So in this case, it's just a 1 and a 2. And then you also write down all the factors. So those are the factors of 2. And then you write down the factors of 5 also, which are just 1 and 5 in this case. And all you're doing is looking to see if you can get two numbers when you combine a number out of one group and a pair of numbers out of one group and a pair of numbers out of the other group. You're looking for being able to create two numbers that, in this case, add to give 7. And the reason why I say add, it's sometimes it's going to be add and sometimes it's going to be subtract. And you look at that sign at the end. That sign tells you whether you're going to be adding or subtracting. And so in this case, I'm going to be adding. And you'll see as we go through several examples here, you see what I'm talking about with adding and subtracting. So how do you take these numbers and combine them off to the side? Well, you could multiply like this. For example, you could take 1 times 1 and 2 times 5. Right? But what's 1 times 1 is 1 and 2 times 5 is 10. And those numbers do not add to give 7. Right? You're looking for two numbers that add to give 7. So that doesn't work. Now, there's another way to multiply them together, though. right? Instead of taking 1 times 1, you take 1 times 5 and 2 times 1. So 1 times 5 is 5, 2 times 1 is 2, and sure enough, those do add to give 7. That's the combination that I want. So I put the 1 and the 2 down in front of the t's, and then how does and remember, these pair up, outside 2 and inside 2. So how does what does the 1 get paired with? It gets paired with the 5. The multiplication that I have off to the right there. And the 2 gets paired with the 1. And then I make sure that I get the signs right. And so this is going to be a positive 1 here. So this is 2t. And this is a positive 5. This is a 5t. And then that gives me my 7t. Right? And I've got it factored. Now, okay, so that should be okay right there. But it's, kind of straightforward when you don't have a lot of factors. So let's start moving into problems where there's a few more factors to worry about. So the next problem I want to look at is 6p squared plus p minus 22. Now don't forget, you're always looking for a combination, or you're looking for a GCF first, but there's no GCF here, so don't forget the GCF. And so now this is a not so easy trinomial, right? It's not so easy because of its 6. And so what I do is I write down all the factors of 6. And the factors of 6 are 1 and 6 and 2 and 3. And then I do the same thing for 22. I write down the factors of 22. You don't worry about the fact that it's negative 22. We're going to worry about the signs in a minute. So the factors for 22 are 1 and 22 and 2 and 11. And so I'm looking to take a pair of factors out of the first group and a pair of factors out of the second group and multiply them together so that I get two numbers that in this case subtract. It's subtract because that's a minus sign right there. That sign on that last term always tells you whether to add or subtract. And so I'm looking for two numbers that subtract to give positive 1. And it's a positive 1 because of that middle term, that 1p right there. So looking for two numbers, I'm going to write that down. Looking for two numbers that subtract to give positive 1. Right? And so this is where the trial and error comes in, and that what are you doing now? You're picking possibilities and seeing if you can get two possibilities that are going to work out, essentially, is what you're trying to do here. All right. And so let me show you. If I pick 1 and 6 and 2 and 11, right? And so remember how you multiply those together. So I have 1 and 6 and 2 and 11. And notice if I take the 6 and the 2 and multiply them, I get 12. And the 1 and the 11 and I multiply them, I get get 11. And what happens when you subtract 12 and 11? You get positive 1, right? 12 minus 11 is positive 1. That's the combination that I want right there, right? And so I write down my factorization from there. So you put the p's down. I know there's got to be a p in the first term of each of the binomials. I put the 1 and the 6 down. So I put a 1 and a 6. By the way, doesn't matter whether you put 6 and 1 or 1 and 6. Either way is okay. And then what are you trying to do? You're trying to pair these up here in the factorization. And remember, they always pair up inside 2 and outside 2. And what are you doing here? You're trying to fit in the 2 and the 11. So let's see, what did the 1 get paired with? The 1 got paired with the 11 down there in the multiplication. So I've got to put the 11 here. And this gives me an 11p. And then that means the 2 has got to go right here, and that gives me a 12p. Like that. And now, which one of those do I want to be positive and which one do I want to be negative? Because I'm going to combine them here, and I need to get a positive 1. Well, the only way to do that would be if the 12 was positive and the 11 was negative. And then that tells me that this 11's got to be negative, and then this 2's got to be positive right here. And I've got my factorization. So the factorization is p plus 2 times 6p minus 11. And remember, you can check the inside 2 and the outside 2 one last time to make sure that those actually give you that positive 1p that you're looking for there in the middle term. All right, so hopefully anybody, please stop me if you have a question as we're going through this. I have no problem stopping if you have a question about some of these. So what I'm going to do is work at some examples, and then obviously what you need to do is practice. And so you're going to get practice out of the textbook, and also I'm going to give you, then you have web-assigned practice also. So you have plenty of opportunities to practice. All right, so the next problem is 12y squared minus 37y plus 21. All right, so this starts to get to be a little bit more involved. The numbers are a little bit bigger. There is no GCF here, right? 3 divides into 12 and 21, but 3 does not divide into 37. And so I don't have any common factors here at all. And this is an example of a not so easy trinomial. If you're watching the recorded version of this later, for those of you who are not watching live, what I would do at this point is I'd stop the video and see if I could work my way through this problem on my own. And then I'd start the video back up and see how I did. Right? Let's see. So you've got, I write down the factors of 12 and 21. So the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. There's actually 3 sets of factors there. And the factors of 21 are 1 and 21 and 3 and 7. So we've got quite a few possibilities to check out here. And what are we doing here? We're looking for 2 numbers that, in this case, add or subtract. Well, this is a plus sign right here, so I'm not going to circle that. So this is going to be add, right, because that's a plus sign. And so looking for 2 numbers that add to give 37. We don't worry about the fact that it's a negative 37 until the end of the problem. 2 numbers that add to give 37. All right, so let's see if as I'm looking through this, is anybody who's watching this live, do you see 2 pairs of numbers that I can get out of there that are going to give me a 37 when I add them together? I'm going to pause here for a second and see if anybody who's watching live can help me with this. Anybody out there? Anybody? Are you guys still alive out there? All right, well, let me see if I can help you then. All right, if I pick 3 and 4 and 3 and 7, right, 3 and 4 and 3 and 7. Notice what happens if I can multiply them this way. If I multiply 3 times 3, I get 9. 4 times 7 is 28. And what happens when I add 9 and 28 together? I get 37. And so that's the combination that I need to factor this polynomial. And so I'm ready to write this out. All right, so I know there's got to be y's in the first terms of each of those binomials. And then what we're doing is we're looking for 2 numbers, we're taking the 3 and the 4, and those out of the first group, those have got to go in front of the y's. So I've got a 3y and a 4y there. And then I'm going to pair these up, outside 2 and inside 2. And going over to the multiplication, the 3's got multiplied together. So I've got to put a 3 on the outside here so that it pairs up with the 3y. And then the 7 has got to obviously go in the other spot. Right, so that gives me a 28y right there and a 9y right there. Now I try to fix the sign so that these work. And so what do I know? That the 7 and the 3 have to multiply to give positive 21. So they've either both got to be positive or they both got to be negative, but they add to give negative 37 in there. And so they're going to both have to be negative. That's the only way to make this work. So that gives me a positive 21, but it also gives me a negative 28y and a negative 9y. And so then I get the negative 37y that I'm looking for. All right, so I've got that polynomial factored. All right, so hopefully you're hanging on and you're doing okay. Please stop me if you have a question. Next problem I want to look at. Okay, let's look at 30x squared plus 105x minus 60. Right. So now make sure you stop yourself here, and you're always looking for a GCF and seeing if you've got a greatest common factor. And there is a GCF here of of 5. At the very least, there's a common factor of 5. And if there's something bigger than 5, we'll find it in the next step. So if we take out a 5, we're left with 6x squared plus 21x minus 12. Now notice that there is still a common factor there. And because there's still a common factor of 3. What that means is that the GCF was not, in fact, 5, that there was a common factor of 5, but that the GCF, since there's another 3 in there that's common, that the GCF should have actually been 15. Right? There's another common factor still left here. So let's see, there's a common factor still left. Which is 3, and so the GCF was not equal to 5, but the GCF instead was equal to 15, right? Because you could take out both the 3 and a 5. So now it makes absolutely no difference how you do this, in that if you didn't see 15, which would be understandable maybe that you didn't see 15, then you could take out the 5 and then take out the 3 afterwards and do this in 2 steps. That would be absolutely okay. And so that you get 15 times 2x squared plus 7x minus 4, like that. Don't worry about that. As long as you see a common factor, take it out. It makes the numbers smaller, and then hopefully it allows you to find the other common factors in the problem. On the other hand, if you went right to 15 and found it, that's fine also. That's great. It doesn't matter whether it took you 2 steps or not. All right, so now you're left with a not so easy trinomial. So I know this is going to break, if it breaks up as a multiplication problem, it's going to be these 2 binomials right here. I know I've got x's and x's here. And let's also think about this for a second. You got a 2x squared, so let's take advantage of that. It's got to be a 2x and a 1x. There's no question that that's got to be true. Or a 1x and a 2x, it doesn't matter. So all you're really trying to do here is fit in factors of 4 so that you can get the inside 2 and the outside 2 to work out right. And the factors of 4 here are 1 and 4 and 2 and 2. And what are you doing? You're looking for 2 numbers that will subtract to give that positive 7. Right? So if I put a 4 here on the outside, that would give me an 8x. And a 1 here, that would give me a 1x. Notice those 2 numbers subtract to give 7. So those are the 2 that I want. So in this case, since the 2 only had 1 set of possibilities, we could have gone ahead and put those in and kind of streamlined our process a little bit. All right, and so then what do I need? I need the 8 to be positive and the 1 to be negative. That's the only way to get a 7 there. And so what do I know? That the 4's got to be positive and the 1's got to be negative. And there's my factorization. All right, so look for a GCF. It would have been harder to factor that problem if you did not take the GCF out, for sure, at the beginning. It makes the numbers smaller. And you're also going to just forget to take the GCF out at the very end of the problem as well. So you just have to be careful. All right, the next problem I'm going to look at is 4a squared plus 5a plus 2. All right, so there's no GCF. The factors of 4 are 1 and 4 and 2 and 2. The factors of 2 are just 1 and 2. And we are looking for two numbers that are going to add, right? This is a plus sign right here. So this is going to be add to give 5. We're going to add to give 5. And if you look through all the different possibilities here, what you're going to find is that there are no numbers that are going to add to give 5. But there's no possibilities will add to give 5. There's no way to get a 5 out of that. That was two sets of numbers there. And so there are no factors. This is not factorable right here. And so you can either write the words not factorable if you want to, or you can write prime. Most of the time in textbook, and I think on WebAssign, they're going to ask you to write the word prime there, which means it's not factorable. There's no way to write it as a multiplication problem unless you use the number 1. So it's just not possible to do. All right, so don't forget that that's a possibility and that that's going to come up when you're looking at factoring trinomials like that, or factoring just in general. So, all right. So a quick rundown then of factoring not so easy trinomials. So now let's move on to perfect square trinomials. Perfect square trinomials are trinomials that factor as the square of a binomial. They factor as something squared. So for example, let me show you for a second. X squared plus 6x plus 9 is an example of a perfect square trinomial because this factors as x plus 3 times x plus 3, or in other words, is x plus 3 squared, like that. That's what we're talking about when we say a perfect square, right? Is that that's a perfect square right there because it's something squared. All right, and so that's what we're looking at trying to do is we're trying to identify, let me write another possibility down here. So x squared minus 10x plus 25. That polynomial, that trinomial factors as x minus 5 times x minus 5, or in other words, x minus 5 squared. And so what we would like to be able to do is we would like to be able to come up with a way of identifying when this is going to happen, when you're going to get the square of a binomial as the factorization, right? And so that's what we're after here. So how do we pick these out from a crowd of trinomials, right? You have this crowd of trinomials on the exam, for example. How are you going to pick out when a perfect square sits in there and separate that from the rest of the group, right? That's what we want to try to do. All right, so this is how you do this. And it's a couple of steps to figure out whether you have a perfect square trinomial or not. All right, so y squared minus 8y plus 16. What you do is if you notice that the first term is a perfect square, it's y squared, and the last term is a perfect square, that's 4. And so that's the first step. So these are both perfect squares. And what I'm going to say is the first and last terms are perfect squares. And then the middle term is twice the product of these two. So what you do is you take these two numbers and you multiply them together. So I get 4y. And then is that middle term, is that twice the product, times 2, in other words? And if it is, then you've got a perfect square trinomial. And it is in this case, isn't it? Because 2 times 4y is 8y. And so this trinomial will factor as y minus 4 quantity squared. It's minus this minus sign here, that sign always is the same as this sign right here. Those are always the same sign. This sign must always be positive. Right? It can never be a negative because then that last term wouldn't be a perfect square. All right, so those are the steps to identify when you have a perfect square trinomial. And so that's what we want to be able to kind of pick out from the crowd, okay? All right, so let's look at some more examples of perfect square trinomials. So let's say we have 25 a squared minus 60ab plus 36b squared, like that. All right, so you first start thinking about a perfect square trinomial if you see that the first term is a perfect square, and it is, it's 5a squared, and the last term is a perfect square, it's 6b squared. And then what do? You take those two numbers and you multiply them together. So 5a times 6b is 30ab. And then you multiply that by 2. And if you get the middle term, then it is a perfect square trinomial. And we do get the middle term here, so it is a perfect square trinomial. And so yes, this works. Right? And so that means we can factor this trinomial as the square of a binomial. And this would be 5a minus 6b. Right? Again, the sign of that middle term is always the sign between these two terms here. Those always are the same. So we've got it factored. Right? And it just makes your life easier if you can factor that a trinomial like this without having to go through and use trial and error or some other things that are going on there. All right, so next problem. This one's going to be messier. And then we're going to be ready to go on to binomials. So you have 90p cubed plus 300p squared q plus 250 pq squared. Yuck. So this looks a little messy. So the first thing to do here is to pick to see if you've got a GCF, right? And so is there a GCF in this problem? And there is, right? There's a common factor here. At the very least, there's a common factor of 10. And I can also take out a p. So let's take out the 10p and see if there's anything else that's left when we do that. So when I take out the 10p, I've got 9p squared plus 30pq plus 25q squared. And sure enough, I'm left with something that doesn't have any more GCFs. And so now I'm ready to see if this is a perfect square trinomial or not. Right? And I do think it might be. The first term is a 3p squared, and the last term is a 5q squared. And when I multiply those together, I get 15pq. Right? And when I take those two and multiply them together, I do get, so I multiply by 2. Right? And so when I multiply those two together, the 2 times the 15pq, I get 30pq. And so this is a perfect square trinomial. So I have 10p, and then I can write out that this is a square, and this would be 3p plus 5q. Don't forget that 10p there, right? Don't play magician and make it go away, right? You got to keep that GCF written down as a factor each time where you don't have the correct factorization. So, all right, anybody have any questions about perfect square trinomials? Any questions at all? Nothing?
I have
No
Trisha?
So going back to the first two problems that you did, we won't have to do that second step where we how can I say it? Okay, so the perfect square, like for the x excuse me, x squared plus 6 plus 9, that was the perfect square, and then you have x plus 3, x plus 3,
Uh-huh.
then
Yeah,
x plus 3 squared.
so you don't have to write the x plus 3 times x plus 3. Now, if you did, there's nothing wrong with that at all. But we're trying to just write it down as a perfect square at the very end. But if you did that,
Oh,
that's definitely not incorrect. So if you took,
okay.
so Trisha, if you took the original polynomial and then you factored it as 10p times 9p squared plus 30 pq plus 25q squared, and then you first wrote this as 10p times 3p plus 5q times 3p plus 5q, that's absolutely correct. But then you ought to, when you see that the factor is the same, 3p plus 5q and 3p plus 5q are the same factor, then you should write it as a perfect square
Okay.
afterward.
So I just want to make sure that we that's not gonna be like we have to put that out.
Oh no, definitely not. Yeah,
Okay.
you're definitely okay. So yeah, not a problem at all. And it is not wrong if you wrote it as 3p plus 5q times 3p plus 5q. If this is what you wrote as the answer in this problem, let's say I gave this problem on a test, and that's what you wrote down, I'm not going to count it wrong. That's correct. You should go ahead and write it as a perfect square also, and just write it as 3p plus 5q quantity squared. And I think it's going to pay off for you in college algebra if you can identify them as perfect squares. But if you didn't write it that way, you've got the right factorization there, and I don't have a problem with that at all.
Okay.
Okay, so like if it'd be the same thing as like if I gave you the number 16, and probably a bad example. If I gave you the number 25 and I said factor 25, and you wrote it as 5 times 5, well, that's the correct factorization. There's no question about that. If you wrote it as 5 squared, that's also the correct factorization. So those are both the same factorizations, just the 5 squared is just written a little bit more efficiently. And, so it's better form, I guess, that you're identifying it as a perfect square like that. But those are both correct. And so I certainly would not have a problem with you writing it that way at all. All right, you're okay?
Yes, I'm fine. Thanks.
Oh, okay, yeah, good question. No, I'm glad. This group of students I've got is kind of quiet in this class, and so which is I'm not used to that. My intermediate algebra class that was online in the fall, I had lots of students, no problems interrupting me and asking me questions, which is what I liked. I wanted people to do that. So don't hesitate to ask a question if you've got it. I don't have a problem stopping and going back over something. All right, let's move on to binomials. That's our last stop of the day, and this will be the last. This is going to take us probably a while to do because there's a lot to do here, and we're going to have to work definitely some examples and just give you a heads up that this is frequently the type of factoring that students struggle with the most when we're factoring polynomials, are factoring binomials. With binomials, what you're doing is you're looking for a pattern, and the pattern there's only 3 patterns that work for binomials. There's the difference of squares, and it says that if you've got a binomial, something with 2 terms in it that happens to be a perfect square minus a perfect square, that you can always write it as a multiplication problem like this, as a plus b times a minus b. Now notice, and Tricia, you and I were just talking about this on the last problem. Notice I wouldn't write this as a square because those are not the same factor, right? I've got an a plus b and an a minus b, so those are not the same factor, so I couldn't write it as a perfect square. I'm just stuck with it as a plus b times a minus b. Expressions like this, by the way, and we're going to use this term a lot, especially in college algebra, but those are called conjugate expressions, or conjugates. Conjugates are 2 binomials that are exactly the same except one's addition and one's subtraction. So a plus b times a minus b. Now, the sum of squares if you have a perfect square plus a perfect square, and this frequently throws students kind of for a loop here, is that the sum of squares, there is no way to write that as a multiplication problem. And so that is a prime polynomial. Unless there's a GCF, it's a prime polynomial. Let me write down also that a squared plus b squared is not equal to a plus b squared. Remember, rules of exponents don't apply to addition problems, and so that's not true right there. So a squared plus b squared is prime. And somewhere along the line, as we go through this and over the next, part of the class, you're gonna confront a squared plus b squared somewhere, and so it's gonna be really tempting to try to factor that, but there's no way to write it as a multiplication problem. It just doesn't work. All right, there are two other ways of factoring binomials, two other patterns. One's called the difference of cubes. It's when you have a perfect cube minus a perfect cube. This is a more complicated multiplication problem. That factors as a minus b times a squared plus ab plus b squared. It factors as a binomial times a trinomial. And the sum of cubes, unlike the sum of squares, the sum of cubes is factorable. There is a way to write it as a multiplication problem. A cubed plus b cubed factors a plus b times a squared minus ab plus b squared. Now notice the only difference in those two are the signs. And so notice that when this is a minus sign, that's going to be a minus sign. And when this is a plus sign, this first term is going to be a plus sign. And then the next sign is always opposite. Right? So this next one is opposite of the first one. And then finally the last one, the last term is always positive. Right? So this one's positive and this one's positive. So it's always a plus sign right there. So a cubed minus b cubed, if you just look at the signs, a cubed minus b cubed has a minus sign like that, and then a plus sign and a plus sign. And then a cubed plus b cubed starts off with a plus sign in there, and then this term's going to be a minus, and then this one's going to be a plus. Right, so you have to kind of keep the signs straight. Something else that we need to write down here before we start in on some examples is the squares. You need to be familiar with perfect squares in order to be able to factor using the difference of squares. And so let's write down the perfect squares here. The perfect squares, are 1, because 1 squared is 1. 2 squared is 4. 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 49, not 79, 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. You ought to know up through 15 squared when you see them. So when you see 121 sitting there somewhere, you say to yourself, hey, I know that's a perfect square, that it's 11 squared. Or if I see 169, hey, I know that's 13 squared, right? And most of those you already know, right? I think all of you probably know at least up through 100. When you look at those numbers, you know that they're perfect squares. Those other ones, you just need to be a little bit more familiar with those. And if you know up through 15 squared, you're going to be okay. Perfect cubes. Probably you're a little bit less familiar with the perfect cubes. So 1 cubed we know is 1. 2 cubed is 8. 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343. At least know up through 7. If you can get up through 7, I think that'll be okay, right? But at least know those on sight when you see them. And it's just going to help you as you're trying to factor some of these problems here. All right, so with all that in mind, I'm going to flip the screen here. I'm going to write those patterns down again at the top of the screen here. So, and then we're going to work through some problems. Right, so we have the difference of squares, the difference of cubes, and the sum of cubes. A little bit of advice on your first exam. What I would do is one of the first, because factoring is going to be a big topic on this first exam, is I would write these forms down on my test. As soon as I got it, I'd write them down somewhere so that I have them. And it says this in the syllabus. I want to make sure you know you will not have notes of any type in front of you during the test, right? All my tests, and by department policy, final exams, you cannot have notes of any type with you during the test. I will allow you the use of a calculator, but not a scientific calculator or a four-function calculator will be fine. But I'm not going to allow you to use notes on the test. So you know that going into it. So what you should do is when you get the test in your hands, make some notes as soon as you get the test, right? So write some things down on the exam so that you have them sitting there in front of you, right? And so these are three forms here that you definitely need to know. All right, so let's look at some examples here. So let's say we have x squared minus, and we're going to start off with some easy ones, x squared minus 64. All right, so first thing is it's a no GCF. There's no common factor there. Second thing is it is a binomial. So if it factors, it's going to factor like one of those three patterns at the top. And so you're trying to match it up with one of those three patterns. Right? And what you see here is that x squared, right? This is what you're trying to do, is you're trying to write both of these terms as perfect squares. Right? And so the question is, can you do what I just did right there? Can you write both of those terms as a square? In other words, can you fill in those parentheses? Right, and the first one you can fill it in, right? It's x squared. And the second one, it is 8 squared, right? And so it is a perfect, both terms are perfect squares. It is subtraction. And so this is going to factor, you're going to write this as a multiplication problem with these two conjugates. It's x plus 8 times x minus 8, right? And you've got the factorization. Now, I'm hoping that a lot of you, decent number of you that are watching this live or recorded, either way, that you already are okay with this. So you've seen differences of squares before, and maybe the cubes also, and that, you know, for the most part, you're okay with this and don't have to spend a lot of time with it. That's what I'm hoping, certainly. All right, the next problem, let's say we have 7x squared minus 63. 7x squared minus 63. Don't forget that look for GCFs before you do anything. And there is a GCF here of 7. And when you take out the 7, you're left with x squared minus 9. Right, so GCF first. Don't forget that. All right, and then you've got a binomial that's left. And can you write both terms as perfect squares, right? The first term is x squared, and the second term is 3 squared. So it is a perfect square minus a perfect square. And so it factors like that first pattern I've got written, and it factors x plus 3 times x minus 3. Right? A plus b times a minus b. All right, next problem. Let's say we have 50a cubed minus 72ab squared. Yuck. All right, so there is a GCF. So we take out the GCF first. Don't forget the GCF. And the GCF in this case would be a 2. I can take a 2 out from the 50 and the 72 both. And there's also a common factor of a. So I can take out a 2a. And I'm left with 25a squared minus 36b b squared. All right, and now the question, can I rewrite both of those terms as perfect squares, right? And so I take the time to try to write both of those as a square. And do I have a square minus a square? Right, and the first one is 5a, and the second one is 6b, right? 5a quantity squared is 25a squared. 6b quantity squared is 36b squared. So it is a perfect square minus a perfect square. So this is 2a. Don't forget the GCF at the beginning. And then you can write out the two factors, 5a plus 6b and 5a minus 6b. And you've got it written as a multiplication problem. All right, this just takes some practice more than anything else. All right, nobody is saying anything, so I'm assuming we are pretty good with this so far. Well, hold on real quick. Let me, I'm going to actually copy our three forms down, and I'm going to continue to write those down. Copy those, paste them onto the next screen. So I have them sitting in front of me for each one of these screens here. All right, the next example. Let's say we have z to the fourth power minus 16. Okay. Now this is not a, there is no GCF there, that's for sure. But it is, so now the next question is, can I write it as one of those patterns? And I think it might be some squares, so can I write this as a square minus a square? The 16 is easy, that's just 4 squared. The z to the fourth, using rules of exponents, that would be z squared squared. So it is also a perfect square. So this does factor as z squared plus 4 times z squared minus 4, like that. All right, now you're not done yet. You now have two factors, and you have to go back and see if either of those will factor again. Now the first one, don't be tempted here. This is the sum of squares. So the sum of squares is prime, right? So that first factor does not break down again. But the second factor is a square minus a square again. And so that second factor does factor using the difference of squares a second time. So the z squared plus 4 just comes down for the ride because it doesn't break down at all. But the z squared minus 4 does factor as z plus 2 times z minus 2. Sure is tempting to take that z squared plus 4 and try to break it down, but there's just no way to do that so that it factors. No way to do that correctly so that the multiplication problem would give you the original polynomial. All right, so really tempting to, but it's an easy mistake to make. I frequently see mistakes like that, so you've really got to watch that. All right, next example. Let's say we have x cubed minus 8. X cubed minus 8. All right, now there's no GCF, so it's certainly not a square minus a square. The 8's not a square, and the x cubed is not, no way to write that as a square. But is this a cube minus a cube? And it is, isn't it? The first term is x cubed, and the second one, what number do we cube to get 8? That would be 2. And so this is a cube minus a cube. And so this is going to factor as a plus b, and I'm going to write this underneath here, a plus b times a squared plus ab plus b squared, like that. So you've got the a and the b sitting there. If you wrote it as cubes, like I did, if you wrote it as x cubed and 2 cubed, then you've got the a and the b sitting there. And I did make a mistake here. This should be a minus sign right here. Sorry about that. This should be a minus b. And so this is going to be a is x and b is 2. So this is x minus 2 for the binomial. And then you write out the rest of these. So this is a squared. So if you want to, you could just put in some parentheses like this, and I think this is not a bad thing to do, is put in parentheses like that that match up with the pattern. Something squared plus something times something plus something squared. And then you just fill in the somethings, right? This is going to be an x, this is going to be an x, this is going to be a 2, and this is going to be a 2. Right? Just fill them in with the a and the b that you figured out. Now you don't leave it like that. You go ahead and multiply that stuff out. So you get x squared plus 2x plus 4. All right, and we've got a multiplication problem. And believe it or not, if you multiplied that out, you'd get x cubed minus 8. Don't forget that you can always check this. And I frequently get students forgetting that they can check these problems, these factoring problems. But, you know, think about this for a second. You've got x minus 2 times x squared plus 2x plus 4. And it's supposed to be the case that if I multiply those together, I should get x cubed minus 8. Right? And so remember how to do this. This is something we talked about on the first class day last week, is multiply through by x and then multiply through by negative 2. And so when you do that, when you multiply through by x, you get x cubed plus 2x squared plus 4x. And then when you multiply through by negative 2, you get negative 2x squared minus 4x minus 8. And sure enough, look what happens. You get x cubed when you add them, but the squares drop out. Those go away. The x's drop out, and you're left with minus 8. Sure enough, everything drops out, and you're just left with x cubed minus 8 as the final multiplication problem. And so you can check these. Don't forget that you can do that. I frequently get students forgetting that they can check the factoring problems like this. All right. All right, Sandra, welcome. All right, next problem. Let me continue to write these down here. Sandra, welcome. All right, so the next problem, let's see. We'll put this here. So we get, let's say we have 54 x cubed plus 128 y cubed. Yuck. All right, so don't forget, look for a GCF first. Easy to forget that. Look for a GCF. Don't worry about the fact that it's a binomial. You're just looking for GCFs. And so there is a GCF here, isn't there, of 2. So you take out the 2 and you're left with 27x cubed plus 64 y cubed. Right? And now, does this fit one of the patterns at the top of the page there? Is it fit any of those? And because of the way the powers are, the only one you're really looking for is the cubes. And you're taking advantage of the fact that you know that 3 cubed is 27 and 4 cubed is 64. So yeah, this is a cube plus a cube. Right, the first term is 3x quantity cubed. The second term is 4y quantity cubed. And so this is a perfect cube plus a perfect cube. And so we know that we're using that first pattern, or that very last pattern I've got written up there, right, where this is a plus b, and then a squared plus ab plus b squared, like that. All right, so I write down the a and the b right away. So this is 3x and a 4y. 3x plus 4y, like that. And then if I were you, I would go ahead and put in these parentheses in here to keep this straight. That this is something squared plus something times something plus something squared, like that. And then you're just filling it in with what the a and the b values are. So this is a 3x here, a 3x here, a 4y, and a 4y, like that. And so you end up with 2 times 3x plus 4y times 9x squared plus 12xy plus 16y squared, like that. All right, now one thing I want to point out is that, you've got a binomial and a trinomial. The trinomial that you write down is typically not factorable. There are some special situations where it will be factorable, but those are situations we will not encounter in class at all. And so for our purposes, you can kind of assume that that trinomial is going to be prime. Don't try to factor it. It only factors in some unusual situations that we are not going to encounter in class. Okay? And so you've got the factorization. Oh, but again, what have I done? I've kind of screwed up. Nobody's yelled at me, which I'm kind of disappointed at. But I did screw up a sign here, didn't I? And nobody pointed it out. But this should be a minus here. And so this should be a minus right here. I wasn't paying attention to the signs. Right? This is the sum of cubes. And so that sign on the second term of the trinomial has got to be negative. All right, remember that these two signs right here are always opposites, right? And I wasn't writing it down like that. So what I had written down wouldn't have been correct, because if I tried to multiply it out, I would not have gotten the original polynomial back. All right, so there's my trinomial. I've got that worked out. So hopefully you're doing okay and you're following this all right, and nobody's having too much of an issue with this. All right, so the next problem I want to look at. Let's look at, let's say we have 32 p cubed minus 800 p. Yuck. Right, and so at first when you look at you see the 800, you kind of freak out and go, oh my gosh, the number's huge. There's no way I'm going to work this out. But, think about the GCFs here, and there's a relatively easy factor to identify that's common, and that's 8. Now, there might be something bigger than 8. I don't know that, but I know for sure 8 is going to go into both 32 and into 800. So if I take out the 8 and the p, I'm left with 4p squared minus 100. Now, this is a common place for a student to make a mistake, because I'll see students all the time say, hey, this is a perfect square, which it is, that's true, and 100 is a perfect square, which it is, that's true. And so I'll see a student write this as 8p times 2p plus 10 times 2p minus 10, a plus b times a minus b, and they think, hey, I'm done, I've got it worked out right. The problem is that student still left some common factors in the 2p plus 10 and the 2p minus 10, and so this is not finished right here. Very common mistake that I see students make. Very common. And so instead, if you see the 8's the common factor and you factor it like this, then you have to look for a common factor again, and there is another common factor, and that is 2, and so you've got to take the 2 out. No, it'd be nice if I wrote it right. It's 4, I'm sorry. So take out a 4, and then that would leave you with p squared minus 25, like that. And so that gives you 32p times p squared minus 25, and then factor the p squared minus 25, which is the difference of two squares. And so you have 32p times p plus 5 times p minus 5. So you've really got to be careful. Do you see why that second one, or the first one I did, was not finished? And so you would get penalized for that. It's not like I'm going to take off full credit for that or anything like that. I definitely am not going to do that. But I am going to penalize you for it if you don't finish the factorization. So you really need to be kind of careful about that. All right, let's see. Let's look at another problem. Let's look at let's look at this one right here. Let's say, so this is going to be 14 k to the 4th times p plus 112 k times p to the fourth. Right, and also wanted to make sure I've got these forms written on the page. I'll put them at the bottom this time. So we have those sitting in front of us. All right, so in this, I think this is going to be our last problem of the day here. So first of all, is there a GCF, right? And that's our first question. And there is a GCF here, clearly. And so if you think about this for a second, if you project ahead a little bit, there's actually a common factor of 14, but if you don't see that, that's okay. But there's clearly a factor of 2, and then there's a k and a p. So if you take out the 2 and the k and the p, then you're left with 7 k cubed plus 56 times p cubed. And now it's easier to see that there's still another common factor. And the next common factor, so there's still a common factor, right? And that common factor is 7. So take out the 7, and then that leaves you with k cubed plus 8p cubed. So that gives me 14 kp times k cubed plus 8p cubed. And then you look at those two terms and you see if, because that's a binomial, you see if it fits one of the patterns that you've got sitting below there. And it is a cube plus a cube, right? K cubed is obviously k cubed, and then 8p cubed is 2p quantity cubed. And so this will factor using the sum of cubes form. Let's see if I can get the signs right this time. So that's going to be a plus there, and then a minus and a plus, okay? And remember, this is a plus b, a squared minus ab plus b squared, right? So this is going to be a k and a 2p right here. And I'm going to write it out with these parentheses in here. And so then this is a k right here, and a k, and a 2p, and a 2p. And that last one's squared there, yeah. And so you get 14 kp times k plus 2p times k squared minus 2kp, or 2pk either way, plus 4p squared at the end there. The common mistake that I'll see on this problem, and some other ones I've written down also, is the student will work through this beautifully, have everything right, but then I want you to look really carefully at where the mistake is. And the mistake here is that very last term. And notice that that student wrote 2p squared, but that exponent of 2 is only on the p right there, and it is not on the 2. There's got to be parentheses there. And so that student failed to square that 2 and wrote that last term incorrectly. So be really careful about something like that. All right, if there are no, let's see, I'm going to see if there's any questions, but I'm going to write down the homework from the textbook. Remember, this is for practice. This is not anything that's graded. You need to be working on WebAssign here, but these are really good practice problems, and I would certainly advise trying to work through some of these, if at all possible. So 7.3, which is page 831. And I know it's a lot of problems, and I'm not saying work them all, definitely not. It's a lot of problems here. But you have 139 through 207, and again, I might try every other odd there. At least do some of those odds, even if it's not every other odd. At least try to do some of those. Don't forget that the odd answers are at the back also. And then section 7.4, which is page 848. On that page, 215 through 271. And again, every other odd there as well. That would give you great practice on these problems. So, all right, does anybody have any questions that they want to ask here at the end?
What book is this? The homework practice?
This is from the OpenStax textbook. And so remember, I've given you instructions on your syllabus and on the Google site both for how you can download this book. And so if you just go to follow the directions in the syllabus, you can actually download the book. And that's what I would do is I'd download it so you have it on your desktop somewhere. And then that's what I'm referring to.
Okay.
Any other questions anybody's got?
I'm sure I'll have some later after I do the practice.
That's fine. Absolutely. Well, I'll be back online in again about 30 minutes from 11 to 12 today, and then again this evening, 8:30 to 9:30. So if any of you guys have questions or anybody who's watching the recorded video, if you have questions, do not hesitate to come by and ask me some questions. I have no problems helping you out. All right. So otherwise, I have a great day. I will see you at lecture on Thursday morning.
I have one question.